Good afternoon, everyone. Today we're going to start our discussion on another form of regression, which is logistic regression. As I mentioned before, I'm going to just have to record the discussion on the continuation of the discussion on regression diagnostics. So we move on now to logistic, and then next meeting we go do quantile regression, and then we also have a discussion on moderating and mediating activities, variables. And then we go to time series. And the rest will be about time series already. Garch model and ARIMA and Garch modeling. Okay, so let's load first our data, the data that I shared with you. Control-Alt-I, library. Let's load tidyverse. Okay, tidyverse first. Let me run this. And then let me run. So let's create this object. Okay, let me just call it data or dat, shortcut for data. Okay, so that is read underscore CSV. Okay, since it's already loaded in our project, you can just access binary.csv. Okay, and then column underscore names is equal to T, true. And then we get view natin, view that. And then let's get the structure and the summary. Okay, so let me first load our data. So make sure you loaded it in the same folder. So our data has 404 columns, 400 rows. Okay, and let's take a look at what this data is. Let's view the data. Okay, so this is, we have 4 variables here, GRE, GPA, and rank. GRE and GPA are scores, individual scores on aptitude and scholastic aptitude. The rank here pertains to the rank of the school where the student came from. 1 means top level school, and 3 and 4 means the lower ranked schools. 2 is just median. Okay, and this set of respondents, 400, we have this whether the student was admitted to the university or not. So we would like to model here if GRE and GPA and the rank of the school where the student came from in high school are predictors of whether a student will be admitted or not in school. So this is an example of logistic regression. Why is it called logistic? Okay, we'll discuss that in a while. It comes from the logit function, okay, which is the log of the probability of being accepted divided by the probability of not being accepted. So that's what we call the P over 1 minus P is the odds ratio. We'll discuss that in a while. All right. So let's take a look at the structure of our data. So this is a data frame. Admit is numeric, GRE is numeric, GPA is numeric, okay, and rank is numeric. Okay, perhaps you already noticed something here that admit is numeric, so we might have a problem with that because admit should not be numeric, rather it should be a factor. Now, what sets apart logistic regression with the ordinary multiple linear regression? When you have a model where your variable of interest, the dependent variable, takes the value of a binary value, either 0 or 1, or it answers the question yes or no. So, for example, will this person buy this object for marketing? For example, they can do logistic regression. Given certain parameters, will this person buy a particular product? For example, insurance. No? will this person buy insurance given certain parameters? Or will this person lose his life? Okay, so given, for example, certain attributes like BP or certain mga blood measures, etc. Will this person or does this person does he or she have cancer, for example? So that's a yes or no question. So topics like that, class, okay, fall under the purview of a logistic regression. Normally, people will not compute for the probabilities. They will compute for the probabilities with the end goal in mind of determining whether that person should fall in this category or in the other category. Okay, so if there are two categories, then that's what we call binary logistic regression. If there are three categories or more, then that's what we call multinomial logistic regression. It's still logistic regression, but it's a multinomial because there are more than two. For example, a study like you take a look at a person, whether he's, let's say, ano ba, yung normal ba or suspect ba siya or pathologic ba siya? A health problem like that. So does this person have normal, let's say, BP or whatever metric they're using? Or is he suspect to have cancer? Or is this person pathologic? So malamang may cancer siya. So that falls under what we call multinomial logistic regression. In this subject, we're not going to take that. Kasi pag alam niyo yung logistic regression, madali na makuha yung multinomial. So rather, I would spend some time doing quantile regression and yung may moderating and mediating variables kasi yun ang madalas na ginagamit din sa mga thesis ng finance. Okay. So we took a look at the structure and then the summary. Okay. You know this, 5 number summaries. Ang relevant lang dyan yung GRE, GPA. Ito, hindi. Kasi rank should be considered a factor kasi classifier yan kung 1 kung maganda yung school or 2 median lang, 3 and 4 pangit. Okay, so let's first test. Tingnan muna natin kung let's create a dummy model now. Let's call it mod 0. Let's first see kung we're going to use regression. Okay. But before that, bago tayo mag-regression, today I'm going to introduce to you some things that statisticians, data analysts do when they conduct regression like this. Well, this came from machine learning concepts kasi. Now, so far, ang ginagawa natin, class, di ba, sa multiple linear regression natin, ginagamit natin yung buong data, yung wage data natin, 526 observations. We used everything to model it. Now, the disadvantage of that is you might be coming up with an overfitted model. Overfitted kasi ginamit natin lahat ng data natin. What's usually being done is you split your data. So, sa machine learning, ginagawa, you have the data set, okay? Kunyari, 526 yan sa wage data natin. What's usually done is we're going to split this into what we call the training data set. Training. And then we have the testing data set. And others have 3, Meron pang isa, yung validating data set. Validation. So tatlo pa nga yung iba, ginagawa nilang, they split it into 3. For our purposes, we'll just split it into 2, training data set and testing data set. What's the purpose of this? The purpose of this is to prevent or avoid overfitting. Ano yung overfitting? Okay, ginagamit natin yung yung model natin, lahat ng data points, so that when you have new data points, parang masyado ng we have created a model that was really fitted for all of these data points. So when something new comes up, it might perform well in predicting the outcome of those other samples. So as I said, what's being done is to split the data. So ang gagawin, magkakaroon ng training data, ito yung i-run, okay? Then we will study ano yung residuals nito, ano yung mga maling prediction. Tapos, gamitin natin itong test data to see if the model will work well also in the testing data. For others, meron pang validation data. So tatlo yung splits. So as I said, for us, we'll just take a look at two test data sets. So the original of 400, kasi 400 yung observations natin, split natin yan. The first one will go to the training data set. Usually ito yung mas malaki yung proportion. And then after we have come up with the model, gamitin natin yung model and then i-predict natin si testing data. And let's see kung maganda pa rin performance siya in predicting this data set which has not yet been seen by the model. Ang nakita lang ng model na data, yung training data. No? Tapos, gagamitin natin yung model na yun, whatever that model is. Kunyari, kung regression yan, di ba may equation of y is equal to beta null plus beta 1, x1, etc. Where you have the values of your parameters, yung beta null, beta 1, etc. Then gagamitin natin yung model na yun to predict the values of testing data. So, mako-compare natin. Okay? All right. So that's what we're going to do now. Magkakaroon tayo ng training at saka testing data. All right. So, i-ano muna natin, no? So let's do that. Let's first mag-partition tayo ng data natin. Partition data set into two. Into two, yun yung training natin and testing data. Okay. So how do we do that? No? We can make use of, you remember this function, yung sample function. Naalala nyo to? Tapos tignan natin tong coming from the base package. Okay, so here you have sample ng either a vector of one or more elements from which to choose. So sample, ilan yung sample natin na gagawin. So sa atin, in our case, we will make two samples. One is a testing and one is a training. And then ito, well, yung x natin, vector, no? Ito yung natin. Ito yung data natin, yung dot natin. Okay. And then yung size natin will be the number of items to choose from. Okay. And then replace is equal to false. And then yung probability. Ano yung replace is equal to false? Yung replacement, as imagine a container. Okay, you have this container. Tapos let's say there are marbles here inside. Pag sinabing with replacement, if you get this, nag-draw out ka ng sample randomly. If you get this, if it's replace is equal to false, ibig sabihin without replacement, you don't return that marble here anymore. No? Hindi na siya. Ibig sabihin, there's no chance for us to draw this marble again. Kung cards yan, 52 cards, a deck of cards. If you, for example, draw out a flower, okay, or a spade, then if you draw that out, there's no chance for that to be drawn out again. Why? Because replace is equal to false. If this was true with replacement yun, ibig sabihin, when we draw out that object, ibabalik pa yun. So there's still the possibility that you'll be able to draw again that item, that object. Okay? So ito, it splits, if we use 2, kasi ita-test natin, at saka ita-train natin, at saka ita-test natin. So split natin yung data natin, itong dot natin, into 2. And then we identify kung ano yung probability, kung ilang % pupunta sa training, ilang % pupunta sa testing. Okay? So we will now have a data set called train. And then we run our model there. Check natin yung kung how successful is the model in predicting yung kung na-admit ba yung yung person or not. And then we run it. I-test natin dun sa testing data and see how our model is able to predict also a data set that it has not yet seen. Pag sinabing seen, hindi pa niya nakita kasi when we run the model, when we generated the model, yung training lang to. Kaya hindi niya alam tong testing data. Okay? Any questions so far, class? Clear ba yun? Clear? Okay. Feedback, please. Okay, thank you. All right. Yung iba? Okay, so let's do this. Yung split natin yung data natin. So we can make use of this sample function to split our data. Okay, so let's create this, an object. Let's call it, kahit ano na lang, no? Tawagin natin group, no? GRP. Group na lang. No? Group. So we do sample. And then, ano yung kailangan? X. Ano yung X natin? X natin class is, ilan ba yung, into how many groups are we going to split our data? Into 2, right? And ano yung size? Ano yung size ng data natin? Okay, it's 400 observations. I will not write 400 there. I'll just show you. I'll just use the n row ng dot. No? That's our object. So of course we know that will give us 400. And then, okay, we can use replace is equal to true. Okay lang yan. Replace is equal to 3t, true, capital dapat. Okay. And then let's identify kung ano yung probability natin. Yung probability class, okay, minsan it's 60, 70, 60% na pupunta sa training data. It depends on the size of the data. In this case, medyo konti lang data natin, 400 lang. So maybe we can use yung probabilities natin, yung division ng ano natin ng data natin is C 80-20. Let's make it 80-20. Okay? So approximately around 80% pupunta sa kasi probabilities to, di ba? So magdo-draw out ng probabilities yung isang group 80% siya ng data. Yung isang group 20%. So it can be done several ways, no? All right. So let's run this. So we have now this group. You notice now that meron ng values dito, no? If you take a look at this, meron ng 1, 1, 1, 2, 1, 1, 1, 2, etc. Now, do we have the same? Okay, let me get the... Okay. Let me... head ng GRP. Okay, and then let's get the first 20. Okay. I'm having 1, 1, 1, 1, 2. Okay, ito yung ano ko. Which means that yung first observation ng data natin, which is this one, yung first observation niya, pupunta sa first group yan. Kasi this will be divided into 2 groups, no? So yung mga 1 dito, pupunta sa first group. So yung mga 2, they will go to the second group. Natural class, we know that those members of group 2 will be smaller kasi 20% lang sila. Okay? Pareto ba siya? 80-20 rule? Okay. Good question, Stephen. Okay, I'm not... okay. In what instance kaya siya pwedeng maging pareto? Okay, I'm not sure.
I was just curious po kasi in my other subject,
Yeah,
parang
totoo.
sinasabi nila na pareto.
Yeah, pareto. Pero in this case kasi, it was just splitting your data into 2 sets. No? Ang context kasi ng Pareto, well, you can have different contexts of Pareto diagrams, no? Pero I'm not just too sure if yung Pareto can be applied here, yung concept ng 80-20 rule. Okay? So, Stephen, I'm sorry, I'm not sure, no? Kung yung 80-20, kasi pwede namang 60-40. Hindi naman siya hard and fast rule na 80-20 yung distribution ng yung pag-split ng data natin. We're just using 80-20 kasi konti lang yung natin, yung data set natin 400. Okay? Sometimes we can use 70-30 or 60-40 depende dun sa sample size natin. So maybe yeah, I think the answer there is hindi siya connected, no, yung 80-20 ng Pareto. Kasi I think yung sa Pareto diagram, 80-20 fixed na proportion yan. But here it's just arbitrary. It can be 60-40, it can be 70-30. Diba, na-discuss nyo ba na ang Pareto pwedeng 80-20, Stephen?
Yes, sir.
Na pwedeng 70-30 ang Pareto? Or it's always 80-20?
Mostly 80-20 po.
Yeah,
Kasi it's like yung distribution po.
Yeah.
Lagi siyang ganun.
Yeah, okay. Yeah, I think that's what I know also na ang Pareto is specifically 80-20, no? It just happened na ang ginamit natin 80-20. We could have used 75-25. Okay, so
I see, sir.
okay, in this case, it's not really pertaining to the Pareto rule ng 80-20. Okay, thank you so much, Stephen, for that question. Okay, all right. So now, what do we do now? We will now split our data kasi meron na tayong pero nga pala, back to my question, do we have the same sample for the group 1, 1, 1, 1, 2 ba rin kayo? Or do you have a different sample? Okay, Krisha, thank you. No. Okay, how about the others? May I have your feedback? Kung pare-pareho tayo ng Si Krisha, hindi kami pareho. Margaret, hindi rin. Okay. All right. Most probably class. Kasi random to eh. So how do we make it the same? How do we make our distribution the same? Para pareho yung data na tinitingnan natin. Para pareho yung output natin. Okay. Yes, thank you. You're correct, Krisha. Krisha, paki-share yung answer mo sa lahat. Okay, Kezia, thank you din. Kezia, thank you. And Krisha, you're correct. It's set that seed. So mag-set that seed tayo nito, class dito. So that we have the same distribution of random numbers. Let's just use 1, 2, 3, 4. Okay, and then let's run this. Okay, and if we go back to yung head, all right. So 1, 1, 1, 2, etc. So 18 ko, 18th observation, 1, 1, 1. Okay, so dito sa first to 17th, dalawa yung 2s, no? And the rest are 1. Okay, now, do we have the same sampling distribution? Same na ba? Okay, yes, good. All right, I was expecting that kasi because of the set that scene. Okay, so let's now go to split na natin yung data natin. Okay, thank you. Thank you for your responses. Okay, Control-Alt-I. Okay, let's create this group. Let's call it train. This we're going to use for our training. Ita-train natin yung data natin, which means that we're going to expose this or use this data to run our logistic regression. Okay, so again, by way of reminder, class, pag binary logistic regression, the variable of interest, the dependent variable should be binary. Okay, it can be 0 or 1, true or false. Basta sinasagot natin is yes or no, or true or false, or may cancer ba o wala, may sakit ba o wala, magbabayad ba to o hindi, should we grant credit card to this one or hindi, magdi-default ba to o hindi. These questions, class, these questions are answerable by a yes or no. So yung mga ganong klaseng regression, yan, binary logistic regression yan. Okay, so let's now get this. Yung train natin, ang gagawin natin, yung data natin na dot, okay, we're going to subset it. isa-subset natin yung yung object natin na dot, and then sabihin natin ng lahat ng sa GRP natin sa group natin na equal to, notice kas dalawang equal to yan hindi mag-work yan pag isang equal to lang. Group is equal to 1, and then lahat ng rows kasama. We'll call it train data set, and the other one, test data set, will be same thing from the dot object consisting of the 400 observations. Subset ulit natin, si GRP, yung group na ginawa natin, should be equal to 2. And then comma. All right, and row, column. Okay, so let's take a look at this. Run natin. So meron na tayong train. Take note, si train, 325 observations, more or less mga 80% yon. Okay, 80% ng 400, that's around 320. And then the test data set is 325. Okay. Let's view. View natin class, si train. Control Alt I. Let's just view our train data set. Okay. Ayan. So this is our train data set. No? Ilan siya? 325 observations. Okay, so ito yung admit natin. Admit, GRE, GPA, rank. Okay? Right, any questions? And if you also view si test data set. Okay, ito si test data set, no? 75 observations. Andun pa rin yung admit, yung complete na data set. Okay, now I forgot, bago natin, tingnan muna natin let me just insert it here. We'd like to know, siyempre alamin muna natin data natin. Let's use the crosstabs, crosstabs function. And then i-plot natin si, we use tilde, admit. Okay, with rank. Tingnan natin kung ano yung parehong categorical variables on admit saka si rank. And our data is equal to that. Okay, let's see what happens. Tingnan natin kung ano yung ilan yung na-admit sa rank 1, rank 2, rank 3, ilan yung hindi na-admit. Okay, all right. You can see here the cross tabulation. Okay, so this is admit 0 or 1, this is rank. So for rank 1 schools, 33 yung na-admit, 28 yung hindi na-admit. Okay, so more than 50% yung yung success rate. Sa rank 2, 54 were accepted, 97 were not. Sa rank 3, 28 accepted, 93 not. Okay, actually pwede natin gawin proportion yan, but I'll leave that to you, class. Modify nyo lang ang proportion yan. And then I think the least performer is rank 4 or rank 3, maybe, any one of them. You can check the proportion of that. Only 12. In terms of number of passes, si rank 2 ang pinakamarami, 54. But in terms of, kaso ang pinakamarami rin siyang applicants. No? But in terms of quality, that remains to be seen. Pero malamang si, quality of course, si rank 1. Kasi more than 50% yung pumasa, right? Ito hindi. 54 lang out of, wait. 30, mas marami kasi yung yung pumasa. So more than 50% yan. Ito hindi, class. Mga 1/3 lang to. Okay. All right. Any questions so far? Class? Okay. Okay, good. Now, let's try Control Alt I. Okay, what will happen if subukan muna natin class sa sa buong sa test date. Kaso ang problema nito pag na niya, narana natin dun, baka magka-problema tayo. All right. So let's do this first. Okay, may mali nga ako dito eh. Dapat kinonvert muna natin, no? Okay, I think mali. Before we even split, dapat kasi si dependent variable natin, si admit, that should be a factor. So let's convert. So si dot natin, dot, using the initial dot admit. Okay, we make it as that factor. Okay, as that factor. So we're going to replace the admit data, which is numeric. Diba numeric kanina nakita natin with a factor. Control C, Control V. Okay, and also yung isa, no? Si ano kasi, si rank. Okay, rank, we also convert it into a factor. Rank ng school, 1, 2, 3, 4. Okay, so we run this. So if we check the yung structure ni admit. Hindi. Structure ni, ano yung data natin ni that? Okay, ang structure ni that is, alright, si admit factor na siya. Factor, si rank factor din. Okay. And then we rerun this, no? Kasi kanina, asan na yung ano natin? Okay, dapat dito to sa simula. Control X. Okay. Before this, Control V. Okay, now now that we have converted admit and rank as a factor, let's now redo this. Okay, so we're redoing it. And then, dapat sa initial din to, no? Sorry for the Control X. Na lang sa simulation. Okay. So, converted na yung mga natin variables natin, mga factors na siya. Let's try this time. Okay. If we're going to do yung simple regression, tapos yung data natin binary, what will happen? What will happen? Sige nga, subukan natin. Let's create this object. Let me just call it mod 0. No? Mod 0 siya. And it will be ln admit regressed on. Saan natin i-regress? Sa lahat na, diba? Yung GRE, GPA, and then the rank data is equal to that. All right. Let's see what happens, class. Control Enter. Summary na natin para one-stop shop. Okay. What happens, class? Error. Error in quantile. Unordered factors are not allowed. Okay. So hindi niya tinatanggap, no? Kasi si natin, si admit, 0 and 1s lang to, no? And siya yung ginawa nating dependent variable. Alright? So what do we do now? Hindi pa pwede yun. So let's so mag-mod 1 tayo. Model 1. Just to be sure, let me rerun this. Okay, so let's now create model 1. Okay. And this time, we're not going to use LM. Pag logistic regression, we use the generalized linear model. Okay. GLM. So that's generalized linear model. Okay, before we continue, let's seek some information about GLM. Yeah. So GLM from the stats package, it's used for fitting generalized linear models. It's used to fit generalized linear models specified by a symbolic description of the linear predictor and the description of the error distribution. So, ano yung mga descriptor ng distribution? Okay. Let's go here. Okay, hinahanap ko yung distribution niya. Okay, ito yung mga family, ano? Data, weights. Nakalagay dito yun. It's here. Why can't I see it? Asan na yung family? May isa akong nakita, Pozon. Pero may iba pa yan, no? Okay, hindi ko makita siya class, pero yung family of values na ito, no? The family object used, let me click this. Ano may mga family? Okay. Pwedeng binomial, Gaussian, gamma distribution, inverse Gaussian, Poisson, quasi-binomial, quasi-Poisson. Okay, so iba-iba, no? Sa atin, ang gagamitin natin si binomial. Ang link niya, logit, no? Si gamma inverse, may inverse Gaussian pa. No? Okay? So, for our purposes, binomial yung ano natin. Binomial yung data natin. Therefore, sige, tuloy natin to. We will now have admit and regressed on, oops, shift tilde, regressed on GRE plus GPA plus rank. Okay. Data is equal to, anong data to class? What data? Data is equal to, hello class, ano yung data natin? Diba si train? Si train, gagamitin natin ng data. Okay. What happens when we run this? Pag rinan natin, okay, nag-e-error siya. No? Nag-e-error siya. Bakit siya nag-e-error? Although nag-GLM tayo, okay, tapos i-admit yung ano natin, yung yung binary yan, okay, ang error dito, hindi natin define kung anong family to. Okay, so we have to define that this is coming from family niya, family is equal to, what do you think, class? You guess it right, binomial. Ayan. Kailangan i-identify natin yung family ng generalized linear model kasi marami yan eh. Okay? All right. So let's now run this and see what happens. Okay. So dapat nag-summary na ako. Okay. Let me repeat. Ay, ano nangyari? Tama, linagay ko na to. No? Dapat, sana piniserve ko yung una para nakita natin yung Control C, Control V. Okay, we did this first. Did this not work? Did not work. Even if we use the generalized linear model, which you will have to use if you're doing binomial logistic regression. Hindi LM, generalized LM. So, dito tinanggal natin yung ano, no? Wala dito yung family. You have to define the family. Okay, so let's run this. Ganun pa rin, admit, regression, GRE, GPA, and rank. Ang data natin, the data that we're going to use is this train data and then family binomial. Let's run this. Okay, then summary natin. Summary, mode 1. Check natin, nag-run na ba? And mode 1, okay? Mode 1 is there. Okay. All right, take a look at this. Huh? Run natin ulit. Okay, we have here the intercept, statistically significant. Then we have GPA, GRE, GPA. GRE is not significant, GPA is significant. Rank 2, okay, not significant. Rank 3 and rank 4 are significant. Okay, now the challenge here, at meron pa sa ilalim, no? Mayroong null deviance. Merong residual deviance. The challenge here is to what? Yung interpretation ito. How do we interpret this? Anyone? Ang interpretation itong estimate na to, GRE, GPA. So what does this mean, class? May nag-chat ka na. Okay. That. Angel, were you trying to answer now?
No, sir. Sorry. Kanina
okay.
pa po yan. Thank
Okay.
you.
Sorry. Okay.
No worries po.
Yeah. So what does this mean, class? We will have to go to the the concept of a logistic regression, yung logic function. Okay, I need to write. So where do I write? Let me open a Word file now. Doon ako susulat. Let me open a new one. File, blank document. Okay. So, sige. So, sa class sa logistic regression, ang equation natin, I hope I can write it well. Let me check kung pwede itong Okay, nagko-conflict kasi minsan yung mouse ko at saka yung digital pad. Sometimes it's difficult for me to write. Okay. Okay. First, define muna natin, di ba? We understand what probabilities are. Okay? Probabilities of P. P is passing or yes. In our case, it's being admitted. Therefore, the probability of quote-unquote losing is 1 minus P. Diba? So these are probabilities. P which is passing or whatever your studying is, whatever the context of your study is. And then this one is 1 minus P, yung the probability of not making it. Meron din tayong tinatawag na odds probability. Odds probability, or oftentimes it's called the odds ratio. Odds ratio is the ratio between the probability of being yes divided by the probability of being no. Okay, that's the odds ratio. And then we have the log odds ratio. By the way, ito, alam natin na 0 to 1 tong value nito. No? 0 to 1. If you're going to look at the yung mga piece natin, 0 to 1 lang yan. And then itong odds ratio, paano to? Can this be 0? So ang minimum value niya is 0. Can this ever be 0? Kasi mangyayari niyan, when will this become 0? Well, of course, class, if P is 0, diba? 1 minus P is 1, so 0 over 1, 0. So pwedeng 0 to. No? So the odds ratio ranges from 0 up to infinity. Yan ang possible na values ng odds ratio. And then we have here the log odds ratio. Log odds ratio, which is what's used in your logistic regression. Log ng P over 1 minus P. So this is your log odds ratio. Okay? And this function, isulat muna natin. Therefore, when our model, di ba yung model natin is beta null, parang regression model plus beta 1 x1 plus beta 2 x2, okay, plus dot plus beta sub n x sub n. Okay, ito yung regression model natin, no? However, sa binary logistic regression, we use what we call logit function. And the logit function is, so this is y, no? Y is equal to this one, but y is equal to yung log odds ratio natin, which is log of P over 1 minus P. Yan. It's equal to this one. So unlike yung ano natin, yung ordinary least squares where y is directly equal to this one, here, ang y natin is equal to the log odds ratio. So that's why this one is equal to this one. Okay? So let's simplify this. So you have log of P over 1 minus P is equal to, okay, andyan na yung beta null plus beta 1 x1, beta 2 x2, plus dot, no? Okay. Now, we need to solve for P. Yung P ang dapat natin malaman kasi ang mangyayari dito sa logistic regression, magka-cut off tayo. If P is less than 0.5, then 0 yung value nun. Okay? So in other words, it will look like a sigmoid curve, parang ganyan, no? Hindi maganda yung pagka-drawing ko. Like this. Hindi maganda yung tumatalikod, tumatabingi. Okay? Anyway, parang ganyan, class, no? So, log of P minus P over 1 minus P, which is the log odds ratio, is equal to this one. Okay, so how do we simplify this? Kasi ang gusto natin malaman yung P. If we're able to solve for P, then we can predict whether this respondent, kung ano man yung kino-consider natin ano, sa study natin. Basta yung P, yung positive, yung yes, yung 1 minus P, yung no. Okay, so this can be simplified by, sulat ulit tayo dito. . That. Dito na lang. I'm going to write it here. Okay, sabi natin that y wala. Y draw ayaw sumulat. Y is equal to box. Ba't siya nagmamark? Okay, I hope this works already. Y is equal to log odds ratio P over 1 minus P. So this is your log odds ratio. No? Log ng odds ratio. And it's equal to, yung kanina, beta null plus beta 1 okay. So sa W1 x2 plus etc. Okay, so how do we now solve for we need to solve for P. So we can do that by exponentiating. So we raise this e to the log, no? And this one also becomes e to that expression. Okay, so this becomes e to the log will cancel out yung log. Kasi inverse function siya eh. So e to the log will become p over 1 minus p. So wala na si log, no? Ito na lang, this will become e to this expression beta 1 plus etc. No? Okay, and then to solve for p, we have p is equal to, we transpose this to the other side, that will be equal to e to the beta null plus beta 1, which is this one, and then we multiply it by 1 minus p, right? Tama class? Yan, 1 minus p. Okay, then we distribute. Okay, i-distribute natin itong terms na to dito. So that's 1 times this amount, e to the, let me just call it e to the b. No? E to the bx, ibig sabihin with x. So that will be the probability is equal to 1 minus p exponential e to the bx. Okay, so i-distribute natin to. 1 times this one is this one. Negative p times this one is negative p times this one. And then we transpose to the other side. No? So magiging p plus. Kasi lilipat yung expression na to. Eh, ayaw pumasok ano ko. Okay. P, ito negative p times e to the bx, di ba? So we transpose that, magiging p e to the bx. Transpose natin, negative siya eh. Negative, no? So naging positive siya. And then we factor this out. So it's equal to, ano na to? Maantong ano, sorry yung ayaw pa rin. Okay, so finally, ano yung finally natin ito? We can now solve for P, di ba? So our P now is P is equal to what? Diba? Kasi magiging P times e to the bx to, no? Tapos itatranspose natin dito yan. Magiging P plus, sulat ko na nga, P times e to the bx, okay, is equal to, yung 1 naman, e to the bx pa rin. Yan. And then we factor out P, this becomes P, okay, is equal to e to the bx over, ano class? 1 plus e to the bx. Okay, so this is the equation. P is equal to e to the bx divided by 1 plus e to the bx. Okay, so let's see. Tingnan natin yung model natin. Okay, may question ba? Ayan, ito si Krisha, no? Alright, so Krisha, ito yung ano, no? Ito yung nasa right-hand side. So when we finalize it, yung original na logit natin, logit function, yung log odds ratio natin, we were able to show that from the original log of P over 1 minus P is equal to yung regular regression equation natin, beta null plus beta 1 x1. Then we simplify this, naging ano siya, P is equal to E to the beta null plus beta 1 x1 plus etc. divided by 1 plus that expression e to the beta null, beta 1, etc. All right, so this is the value of the probability, no? Okay, so tingnan nga natin muna. Okay, clear all drawings. All right, so what are the things that we will see in mod 1? Names, mod 1. All right, so ito yung mga names ng mod 1, ito yung laman, ano? So we also have this. Andun yung coefficients, andun yung fitted values. Okay? Tingnan nga natin class yung ano. So yung equation natin ito kanina versus that model. Ito. Yung summary natin, hindi yan. Ito. Summary mod 1. So that's negative 5.009195 plus 0.0016 times GRE plus 1.6166 times GPA, negative 0.57 times rank 2, etc. No? Ang tanong, ano yung interpretation natin yan? How do we interpret this? Itong 1.166 na yan. Kasi sa ordinary least squares, di ba sabi natin, for every 1 point, kung whatever unit GPA is, for every 1 point increase in GPA, there's a corresponding 1.66 watt. Yun ang question. Kasi di ba yung admit natin na variable, that's 0 or 1 eh. Okay, so how do we now interpret this? Okay, that's the first question. Pangalawa, okay, anong ibig sabihin nitong yung names natin, ito? Okay, so we have this, yung mga fitted values, no? Let's just take a look at the fitted values muna. Head, okay, mod 1, dollar, fitted values. And let's just generate the first 10. Okay, so what's this class? Ano to mga to? Point 21, point 31, what's that? How do we now interpret that class? Yes. Residuals ba siya? Fitted values to So they're the predicted values. So meron tayong 0.213. What's 0.213? So this is something that's quite different from OLS, no? Kasi in the first place, yung equation natin, y is equal to log odds ratio. Hindi ganun sa OLS eh. Sa OLS, pretty straightforward. No? Whatever the value of y is, yun yung value ng pag-interpret natin ng ng marginal effect ng the independent variable on your dependent variable. Okay, pero ito kasi iba, no? Okay? So, okay, sige. First, what will be our equation? What will be our equation? We can see here that GRE is not significant, GPA is significant. Yung rank naman, we expect this kasi dami variable to, rank 2, 3, 4. For as long as may isang significant, di natin pwedeng yan. We cannot remove that. So let's refine our model muna kasi may variable tayo na hindi significant si GRE. Okay? So even before interpreting this, itong mga to, no? Wag mo natin i-interpret kasi hindi pa naman yata yan final model natin. Kasi meron tayong GRE na insignificant. No? And in fact, if we take the Z value, 1.34, si rank may significant kasi. Kaya hindi natin siya pwedeng tanggalin. And it's very consistent naman with the Z value, 1.34. Okay, so let's rerun the model. This one, not yet. So let's call it mod 2. No? Model 2 is GLM natin. Let me just copy the function natin dito. Okay, ito na lang. Control C. Alright, GLM admit, we'll have to remove GRE because that's not significant. So what will remain is GPA and rank. Data is equal to train, family is equal to binomial, then we call this mod 2. And let's run this. Okay, and now we get this equation. So rank 2 is not significant, pero we will still have to put that in kasi yung rank natin significant. So what's our equation, class? Let's write our equation. Y is equal to negative 4.727 plus 1.375 times GPA minus 0.5712 times rank 3 minus 1.16 times rank 2, rank 3, and negative 1.56 times rank 4. All right, so that's our equation. Okay? All right. Now, let's use this equation. Tingnan natin mga coefficients natin. No? Okay. Let's see, model 2 underscore dollar coefficients. Okay, ito. Yan yung coefficients natin. Okay, so let's compute for the value of your y, okay, given this. So sa training natin, di ba ang unang y natin, ito, no? Let's get this, Control C, and then Control V. This natin, sige, Control, Alt, and okay, let's see. So mod 2, coefficients, yung first, yan, negative 4.727, parang hindi natin isulat. So that's the first. Okay, and then this is your, sa tray natin, this is your, and then, hindi lalabas to kasi hindi natin sinama sa GRA's equation. So GPA, 3.61. Okay, so this will be plus 3.61 times your GPA. Ito yung GPA natin. So kunin ko na lang mod 2. Ito mas matagal pero okay lang. Coefficients, okay? And then we get the second element there. Itong second element na to, ito yun, yung GPA. So we're multiplying it with 3.61. Okay, and then si person 1 is rank 3, no? Rank 3 siya, therefore 0 tong rank 2, 0 tong rank 4. Correct? So we will just have to add plus itong effect ng rank 3. So that will be mod 2 coefficients. And then pang ilan siya? 1, 2, 3, 4. We subset it, the fourth element there. Okay, just to check, let me check this. Control C, Control V, negative 1.6. Yan, tama. All right? So what did we do? What did we do, class? We're going to compute for the value of we're going to compute the value of your y, yung first natin, first observation. So si y, which is equal to, diba, y is equal to what? Beta null plus 3.61 times GPA, diba? And then, sorry, yung ano pala to? Ito yung equation natin, diba? All right, so we performed that here. This is the value. So this is actually your, let's see if this will equal your fitted value for observation number 1. So is this your fitted value? Natin. Okay. Negative 0.933. Okay. How does that compare with mod 1 dollar fitted, yung mga fitted values? Okay. Kunin natin yung yung head, kahit yung first 5 ng fitted values. Alright, bakit ito 0.21, 0.31, 0.72? Bakit magkaiba yung fitted value kaysa dun sa value dito? So what's the difference? Anyone, please? Anyone? Okay. In the interest of time, class, ito, what's this? What's this, class? This is your y. And remember, sa logit, this is your log odds ratio. Okay? So, what do we now have, class? Anyone? How do we link this? Ito yung value ng first, no? Ito, negative 0.933. We call this, let's call this fit1. Fit1. Kasi kinuha natin yung mga coefficients tapos rinan natin, minultiply natin dun sa observation 1 values ng train 1. So, hindi pumasok si GRE. GPA is 3.61 times whatever the factor is. And then rank 3. Rank 3 siya, ibig sabihin, hindi papasok si rank 2 at saka si rank 4. Okay? That's why we didn't include this rank 2 and rank 4. Ito lang ang sinama natin. And ano yung lumabas na value? Fit 1 is negative 0.933, no? Ito yung fit 1, 0.933. Anong difference nito at saka ito? Plus. Why is it that yung fitted values natin dito, 0.21, pero dito, nung kinompute natin, 0.93. Kasi, okay. We just discussed the, okay, let me show that to you again. Ito yun, class, ito. Ito. So, hindi pa rin ako makuha, class. Hindi lang siguro maganda yung pagka-explain ko. Remember, your y class is equal to this one, ba? Your y is equal to your log odds ratio. Ito. And then what did we do? What did we do, class? We converted. Okay, we converted it into P. So this is your P. Diba, class? Di pa rin nakuha. What's this, class? What's this? Yung beta null plus beta 1 x1 plus beta 2 x2. That is your, that's your what, class? Ano to? Ito. That's your y, di ba? So this is actually e to the y over 1 plus e to the y. Di ba? Right? O sige, tingnan natin. Before we go, ito lang, no? Okay. Control Alt I. Okay. So, ito class, ito yung y, no? Tama? Now, how do we get, anong relationship niyan dito? Okay, let's solve this, class. So, e to the fit 1, ito yung fit 1, di ba? Ito. Divided by 1, 1 plus e to the fit 1. Okay. What do you get? What do you get there? Anyone, please? Anyone who tried, ano nakuha nyo? Nakahabol ba kayo or ano?
Wait, sir, can you scroll up po sa mod
Sige.
2 part? Ay, nag-error.
Okay,
I'll just rerun it.
sige.
A bit higher po.
A bit higher.
Ayan, wait lang po.
Tinanggal natin yung GRE, no? Kasi hindi siya significant.
Okay, thank you, sir.
Okay. Sige. So, it's already time, class, no? Okay, babalikan natin to next meeting kasi very important to sa atin eh. When we tried to get the fitted values of, okay, tapos dapat dito class ano, no? Nagkamali ako dito, dapat fitted values ni mod 2, doon natin i-compare. No? Mod 2 na tayo, di ba? Alright, yan, class. Actually yan, nakuha ni Krisha eh. Who was that who answered a while ago? Sino ba yung nag-chat kanina? Okay, si Krisha. Krisha, tingnan mo yung ano, answer mo, 0.2822, di ba? Which is this one. Okay? So dito, may model 2 tayo, di ba? I got the head of model 2 yung first 5 values and we get this. So the fitted values class, sagutin ko na, no? The fitted values give us the probabilities. Okay? This is the probability that this person will be accepted. This is the probability that the person will be accepted. Ito, the probability that he will be accepted, no? He or she will be accepted. So ito, probabilities to yung fitted values natin. Ito naman, nung kinompute natin si Y, okay, this is your, ano to? What's this? This is your log odds ratio, di ba? Okay, so yung 0.93 na yan. So we will convert this into probability. What's the probability? Yung equation natin, P is equal to, balik dito, P is equal to E to the beta 1, beta null, beta 1, etc. But that one, yung B1, B2 na yan, that's your Y, no? So that's the same as probability is equal to E to the Y over 1 plus E to the Y. Alright? So when we perform that here, ito, okay, di ba ito yung Y natin, no? Kasi ito, Y is equal to yan eh. Okay, so when we performed, when we substituted Y dito sa E to the Y divided by 1 plus E to the Y, this is, what's this? What's this, class? Ano yung E to the Y na yan? Plus, what's this? What's this, class? This is your p-value. This is your p-value. Ito yun, no? Ito. No? Diba, we computed for p. And it turns out that p is equal to e to the, okay, remember that itong function na to, that's equal to y. Y is equal to beta null plus beta 1 plus beta 2, etc. So your p is equal to e to the y over 1 plus e to the y. And when we substituted that, okay, here, our y is sino kanina, yung fit 1 natin. Okay? So I could have called this y1. No? Gawin natin na y1 siya. Y1. And what do we get here? What's the value of our y for the first observation? It's negative 0.933. So if we convert this into the probability, you have, we use that equation e to the y over 1 plus e to the y. So that's e to the 0.933. Okay, so this becomes y1. This also becomes y1. Okay. If we run this, 0.28229, which is this one. Okay? So, yung makukuha natin class na mga parameters dito sa model natin, okay, this is used in order to compute for ito yung mga log odds natin na gagamitin. Okay? So, makukuha natin dito yung p-value natin. P. Pero sa fitted values, ang binibigay, hindi na yung p-values. Kino-convert na automatically into your probabilities. So, 0.28. Ito daw yung probability na C1 maa-admit. Ano ba answer natin? So, si train, so tama, no? Zero siya, di ba? So, tama yung model natin. Sa number 2, 1 tayo dito pero 0.29 siya. So, mali yung model natin. Sa number 3, 0.68 yung probability. Si number 3, no? Tama, 1 to. Si fourth observation, 0.13 lang yung probability. Pero 1 siya dito. So, mali na naman siya dito. Okay, so next meeting gagawa tayo ng cross tabulation. Titingnan natin ano yung mga tama tayo na ano. Ano yung mga tama na prediction natin at saka ano yung mali. Okay? Because this is already our model. Ito na yung model natin. Yan na. Okay? And then we will also do this for the testing data and see if okay yung model natin dun sa isang data set na hindi pa niya nakikita. Okay? All right. So sorry for the extension. Let me